In this question from JEST 2012, we have an n cross n matrix consisting of all ones. We have to identify the correct statement regarding its eigenvalues. So the matrix that we are given is a matrix like this. It is n cross n matrix. The trace of this matrix is equal to sum of its diagonal elements, which is equal to 1 plus etc plus 1 up to n times. There will be n ones, which means trace is equal to capital N. Now the rank of this matrix is 1. Why? Because rank of a matrix is the maximum number of linearly independent rows or columns, or maximum number of linearly independent columns in the matrix. Now we can see that we can write C1 is equal to C2, column 1 is equal to column 2 is equal to column 3 is equal to etc is equal to Cn. Any column can be written as equal to another column, and for rows also we can write R1 is equal to R2 is equal to R3 is equal to etc is equal to Rn. Therefore all rows are depending on each other. Only one row or one column is independent. Therefore rank is equal to 1. Now for an n cross n matrix, rank of the matrix is equal to rank of matrix. This is equal to number of non-zero eigenvalues. Since rank is equal to 1 here, this implies number of non-zero eigenvalues is equal to 1. We also know that trace of matrix is equal to sum of eigenvalues of matrix Now only one eigenvalue is non-zero. Let us say it is lambda. All the other eigenvalues are 0. Now trace of a matrix is, trace of the given matrix, we found it to be equal to capital N. Therefore we have n is equal to lambda plus 0 etc. There will be n terms like this total. From here we are getting the only non-zero eigenvalue is equal to n and all other eigenvalues are 0. Therefore the correct option here is one eigenvalue is equal to n, the others are equal to 0. Now you can also solve this question using a particular case. Let's take n equal to 2. You can take n equal to 2. Then it will be, let us say matrix is A. It will be 1 1 1 1. In this case, if you solve the determinant equation A minus lambda I equal to 0, then you will get the eigenvalues equal to lambda equal to 0, 2. Now the first option is saying all eigenvalues are equal to 1, which is not correct because we are getting eigenvalues to be equal to 0 and 2. Now second option says all eigenvalues is equal to 0. This is also not correct because one eigenvalue is 2. The third option says all eigenvalues are 1, 2, etc. up to n. According to this, the eigenvalues should be 1 and 2, but this is not correct because we are getting 0 and 2. The final option is correct because one eigenvalue is equal to n, we took n equal to 2, and the other eigenvalue is 0. So you can also take a particular case and then check the correct option.